Hi everyone, so let's talk about the ambiguous case of sine. Now, this hasn't come up very often in exams. It's come up about once, but you never know, it might come up again. It's not covered much in your textbook, so that's why I'll definitely have a look at it here. So, what's ambiguous? Ambiguous means that it's opening to interpretation, that it's not entirely clear. So this is what happens if we have a triangle where we have two sides and an angle that is not the angle between the sides. So in this scenario, this is when we're trying to find an angle and we're not actually sure if it's obtuse or acute. On the information we have, that angle, that unknown angle, could be obtuse, between 90 and 180 degrees, or acute, which is between 0 and 90 degrees. We're not actually sure. When you use your calculator automatically gives you the acute angle. It just gives you the one that's less than 90 degrees. However, with sine, it could be the obtuse. We just don't know. It depends on that triangle. Now, those of you who've done methods, at least in year 11, will understand about that when you think about the circular functions. So if you have a diagram, you must check it to see if that unknown angle is acute or obtuse. Now, if you don't have a diagram, this is when you have to start making some assumptions, or they'll give you more information. So I've got the situation here below. The triangles have two corresponding sides equal, A and B, as well as angle B. So you can see here we've got side A, side B, side B, and angle B. Now, it is not between them, of course. That's the non-included angle. So that's the angle we know. So we don't know what that angle A can be. So if you go on your calculator, you'll see that sine of 110 degrees, let's bring that up. So sine 110 degrees, Control Enter, is the same as sine 70 degrees. Control Enter. Please note I use my approximately equal to get myself that decimal answer. But yet they are the same. So we can't tell what one it will be unless we have a diagram or some kind of indication. So if we're looking for an obtuse angle, remember that sine 180 minus that angle equals that angle theta. So 180 take away theta will give you that obtuse angle. So if you're looking back at this example here, 180 take away 70 gives you 110. I'll go through that again. So 180 take away 70 gives you 110 degrees. Okay, so it just depends on that diagram. So you can see that angle there is acute, it's less than 90 degrees, whereas that one there is obtuse, greater than 90 degrees. Can I zoom it up? Oh yeah, I can. It's even better zoomed up. You can see that distinction even more there. So this is the very sort of complex rule. So I wouldn't expect all of you to know this. So that's side B sine of A. If that times by sine of A is less than the side of A, which is less than the side of B, then two possible triangles exist. Okay, so that means that we don't know whether it's that angle or that angle. We don't know if it's obtuse or acute. Now that's a very sort of complex level of thinking, and that's sort of that higher level one, so maybe not all of you will need to know that, but that's okay. So here again is some worked examples. Correct to the nearest degree, find angle U in a triangle given that T equals 7, side U equals 12, and angle T is 25 degrees. Now, because of that information, because we're given angle T, which is the non-included angle, not between these two, we don't know what the other angle could be. So you can see here, it's shown in this little example here where we've got an obtuse angle there or an acute angle there. So you can see that all the other information is the same. We've got 12 there, 12 there, that's still 7, that's 7, that's still 25 degrees, 25 degrees, but we don't know if this line, if that line T with the line S forms that type of angle or that type of angle. All right, because we only know its length, we don't know any more information. And as we don't know the length of S, that doesn't help us either. So there's two possible angles. Two possible triangles. One where U is acute, one where U is obtuse. We draw both, and then we use our sine rule. We're substituting our knowns and unknowns. So that gives us that. So what I did there is times everything by sine U, then divided by that fraction. Give me sine U equals that. So U equals 46.43 degrees, or U equals 135.57 degrees. So correct to the nearest degree. It's either 46 or 134 degrees. All right, so I'm going to do an example now, and I'll do that in a separate video.